Namaskar. Let us start our live session. Just a minute, we are making some arrangement. Okay, so we are starting our class that is for environmental science. Now, this is my first session that we are carrying out on mobile phone, and from this smartphone, I'm making this recording available. So let us check out first that the way we are going. Uh, Suppose I'm able to deliver complete lecture or some technical errors or error from myself, and like that we are going to discuss first, and then we will start uh, increasing our time period, because as long as this lockdown period is there, we are going to discuss on this social media only. So let us start the topic, environmental science. So first thing that we are discussing about environmental science, many people are having doubt that environmental science means related with pollution only. So answer is no. It is not only related with pollution, in knowledge of this environment. And the first question obvious is there in our mind, that what is environment? So whatever is surrounding us, in vicinity of us, we are considering, other than yourself, everything we have to consider that is as environment. So here, suppose I am now staying at home. So my environment is whatever is there in home, that is my environment. Now suppose I am going to classes, then whatever there around the classes, that is my environment. Suppose a student is there that is going to college, then at that time when he is in college, that time is called as environment of that student. When that student is at home, that is his environment. So like that, environment can be anything which is in surrounding of you. Now in broad sense, we are considering entire this earth as part of our environment, and now we are focusing on the factors of this environment. So broadly speaking, we can classify as biological factor and non-biological factor. So first part, we are discussing about non-biological factor. There may be physical factors, there may be chemical factors, anything that sunlight, heat, then whatever the chemical composition is there of atmosphere, that everything that constitutes about environmental part. That is physical and chemical environment around you, that is non-biological. Whereas if you are talking of biological environment, then whatever the animals, plants, microorganism, and whatever the things are there that is considered under life, that is considered as your biological environment. Now we have to discuss about the certain changes in environment. Now when I am talking that certain changes, what exactly it means? Say, prior to prehistoric period, that means prior to arrival of man on earth, whether earth was all right at that time? The answer, no. Various changes what today we are getting record, accordingly they happen on earth prior to arrival of man. But we believe that after arrival of man on earth, man started playing with environment. Particularly, first time we started playing, that when we discovered the fire. That means we started burning out fuel, that is biological fuel only at that time. And then we started playing. But at that time, our population was very, very less. And it was not having that impact on Earth's atmosphere. But particularly after industrial revolution, which obviously started from England, then spread in America also, first in Europe continent, then America, and then worldwide it spread. At the same time, there is tremendous growth, that is we can consider as explosion in the population of human beings on earth, and therefore the environmental issues started probleming. So the first thing we encountered the problem that is of uh, that problem is not actual problem, but we are considering in environmental issue. We started using the fuel, extraordinary use of fuel, and that's why we are now focusing on energy resources. So why we are considering first as energy resources? The thing is that uh, in primitive category of man, even that Neolithic man, and then onwards Mohenjo-daro, Harappa, that Indus Valley civilization, whatever earlier prehistoric, and after that till industrial revolution, use of fuel was much more limited. But after industrial revolution, use of fuel increased, and therefore first we are now discussing about the changes. But prior to that, we must aware how energy is getting. We are getting energy. So we are now classifying under energy resources. So first we are focusing on energy. First period, that is from prehistoric period till industrial revolution period. What energy sources were available with us? Obvious, from childhood only we are aware that wood, that is the primitive source, then coal, charcoal, certain oils, then even to certain extent we used wind as a source of energy. That's why ship sailing that was there. So that is use of wind. And in certain countries they were using water, the running water, as a source of energy. Like that we were using these resources prior to industrial revolution, and after industrial revolution we added out all these things, continued. Say today also keep in mind more than 50% fuel use is coal. So it is not that after industrial revolution we stop the use of coal or we depend completely on petrol or these petroleum products. So no, we started using this continuously. This type of coal and charcoal, etc. They also continued. So after industrial revolution, we change to certain new energy resources. Out of that, one is petroleum, that is we are considering as petroleum and petroleum products. Then natural gas and some fuel gas, particularly methane, ethane, propane, butane. So like that gases we started using as a fuel. Then the most important thing, that is nuclear energy. So that also we started using. And then uh, the reuse, we can say, or some different way, we started using wind energy, then tidal energy, hydel energy, all these things. So now we have to discuss all these things. So first, we are now focusing on biological fuels. So what is biological fuel? For that purpose, we have to go to the cycle, that how energy is trapped and how energy flow is there on Earth, obviously. So first, the predominant source of energy, that is sun. You are aware that on sun there is nuclear fusion reaction. Now, this nuclear fusion reaction takes place that 4 hydrogen nuclei, they are fusing out to give 1 helium nuclei. In this process, there is little bit mass loss. But you are aware that when mass is the word we are using, that means Einstein is important. And according to his principle, that energy equal to that E equal to m into c square. So like that energy is liberated. I'm revising the process where 4 hydrogen nuclei, they are fusing out together to give 1 helium nucleus. That is simple way. In deep sense, first there is collision of 2 hydrogen nuclei. That means 2 protons. Then these 2 protons are getting converted into deuterium nuclei. Deuterium is isotope of hydrogen. So 1 proton and 1 neutron. That means simple thing is that 1 proton is converted into neutron. Now as 1 proton is converted into neutron, positive charge must be eliminated, and that is massless, almost massless particle, but having little, very, very mass, small mass, almost equivalent to mass of electron, but charge is positive. So we call it as positron. And along with that, a neutrino is also expelled out. So the process I'm revising, two protons, they are colliding with each other, may result in formation of deuterium, that is one proton and one neutron combination, where in this process a positron is expelled out along with neutrino. Now this deuteron means one proton and one neutron combination. Now it is again colliding with another proton. This time they are getting set of two proton and one neutron. This is helium-2, 3. This is very, very unstable for a while. It formed, and then after formation of He2, 3, gamma radiation is emitted. Now this helium-2, 3, what I am speaking, that may not be able to get exactly from non-science student. For them, my simple request is there, visit our channel. There is portion that is called as nuclear chemistry. So in this nuclear chemistry, these all things are there. Otherwise, simple, you can keep in mind 4 hydrogen nuclei, they are combining together to give one helium nuclei. All right. So, but I am explaining for those who can understand. For them, I am explaining little bit in detail. So this is now 2 hydrogen combined together to give one helium, one deuteron. One deuteron combined with again hydrogen, that means proton, to give one helium nucleus. So somebody is commenting out. Let me clarify that this recording I am carrying out from my home, as we are locked down at home, and so board facility is not there with me. And as this is live recording, I can't insert a slide because I have slides. And for those, you can obviously visit our channel UPSC Guru. Subscribe this channel UPSC Guru. During this coming week only, we are adding out this video with slides on that channel, because that is pre-recorded video, whereas this is live recording. Let us start again. Try to imagine. It will be very clear. I'm revising. 2 protons are combining to give one deuteron. This one deuteron is combining with one proton. As deuteron is combining with proton, it gives helium-2, 3. 2 is atomic number and 3 is mass number. So 3 is written on top. So helium-2, 3. It is isotope of helium. And then keep in mind this point, keep in mind, because in future reference we require this point. Helium-2, 3. Now helium-2, 3 will collide with another helium-2, 3. Now just make the practice. At denominator we have 2 plus 2. Denominator not actually, but at baseline, that we can say subscript, we have 2 and 2, that means 4. Whereas at superscript, we have 3 plus 3, that is 6. So you are aware that 4 and 6 is beryllium. Atomic number 4 is beryllium, which is very, very unstable. And then beryllium is splitting out immediately and getting converted into helium-2, 4, which is very, very stable. Along with that, we are getting emission, and tremendous energy is liberated in this process. So this is detailed process. So I am revising again that on Sun, 4 atoms of hydrogen, they combine together to give simply helium. And then this helium is formed on Sun, and tremendous energy is liberated. This is because of there is conversion of mass into energy. Now this energy is spread into the space. You are aware Sun is having tremendous high diameter, that means tremendous surface area, and from surface area this energy is emitted all over the sides of this space. Out of that, 1 divided by 2000 millionth part, I am revising, 1 divided by 2000 millionth part, that energy is receiving on Earth. Average, you are aware that Earth's orbit around Sun is elliptical one, and average distance we are considering as 15 crore kilometer. So by that calculation, we are receiving only 1 upon 2000 millionth part of energy of sun. That is so high that in summer season we are having problem of very high temperature. So that we are calling as very high temperature. Just imagine what will be the temperature on sun. Again, certain mysteries are there. The corona of sun is having very high temperature. Surface of sun is having very low temperature. Very low means around 5 to 6,000 degrees Celsius. And as we are going inside the sun's body, that means towards core of sun, we are getting again high temperature. So these are the things we have to explain. Now that energy is coming to earth. And now our story begins here. Whatever the energy that coming out from sun to earth is simply sent back in the space by earth. Why? Otherwise, you will find there should be gradually increasing temperature of earth. And at formation, whatever the temperature of earth was there, now it must be greater than the exact temperature of earth at that time, which is not. Instead of that, we are getting data that at formation, earth was very hot. Then onwards, it was cooled down. After formation also, many years, even life was there on earth. Then also it was very hot. Evidence, try to recollect our biology classification. In that we discuss about archaebacteria. They are ancient bacteria and they can survive, or rather they survive when temperature is very high, particularly around 80 degrees Celsius plus temperature they can survive. That is the indication that earth cooled down. And then the question is that why it is cooling down. So whatever the insolation means whatever energy emitted by sun that is received by earth, that is reflected back in the space. And therefore we have this problem that we are getting energy, we are using and we are releasing out. Okay, now this is the first part. Now how we are using that energy. So for that purpose, again, we have to switch over to biology side. I'm not going into much of the detail, but two processes I must explain. The first process, that is photosynthesis, and the second process, that is respiration. So first we are discussing a little bit about photosynthesis. Now photosynthesis is carried out with help of a pigment that is called as chlorophyll. Those who are from biology side, they are aware that xanthophyll and variety of these pigments are there. But simply we can call it as only chlorophyll. So that is responsible for trapping solar energy. But what is meaning that solar energy is trapped? The thing is that carbon dioxide is there in atmosphere. That carbon dioxide, we means that in process, it is combined with water molecule. Water molecule is undergoing splitting, and then there is combination or rearrangement of molecule, and this is for that purpose energy is required, and this energy what is required, that is solar energy. That solar energy is trapped here, and we are getting the formation of a energy rich molecule that is called as glucose, that is C6H12O6. This is monosaccharide. I am revising the process. Carbon dioxide is combining with water molecule, and in presence of sunlight, and obviously the enzyme is there, that is the chemical is there, that is chlorophyll. We are getting splitting of water molecule, and then we are getting here C6H12O6, which is energy rich molecule, plus oxygen is liberated from water. This is nuclear test is carried out, radioactivity test is carried out, and we determine that this is according to Hill's process. Oxygen is liberated, and that liberated oxygen is received in atmosphere. Now see the balancing, how they achieve. The first part, we are discussing, that is photosynthesis, where carbon dioxide is combining with water, and then we are getting here glucose, that is simple molecule, simple monosaccharide. Oxygen is liberated in the process. This is energy trapping process. This way solar energy is trapped. Now this monosaccharide means what? Simple molecule of glucose. So glucose, then fructose, these are categorized as monosaccharide. Then plants are undergoing process, and we are having the further part that is called as disaccharide, trisaccharide, polysaccharide, like that. Say for example, you are aware starch. Starch is example of polysaccharide. Sugar, that is cane sugar, that is called as sucrose, that is example of disaccharide. So like that, we are getting variety of these glucose, fructose, like that molecules. They are energy rich molecule. Then during the process in the plant, they are further converted into uh, fat, protein, like that. And this is the generation of biomass, where solar energy is trapped there. And then this trapped solar energy is used by these plants for themselves, for building out their body. And then whatever we are observing, that is biomass, that is created by this plant. That's why we are calling these plants as producers. Now you are aware of food chain and food web. Through this food chain and food web, primary consumers are consuming out them, then secondary, tertiary, and like that, the biomass is produced. So I'm ending out this today's lecture here, that how biomass is produced. In next lecture, we are going to discuss about the respiration process. But prior to that, I must again explain you that these video lectures we are making live, but the formatted lectures are available on UPSC Guru. Step by step, we are going to add these lectures on UPSC Guru. So kindly subscribe that channel. There we will get these lectures entirely. Thanks.